Good morning, everybody. Thank you for joining us on our first webinar for Thermal Vision Ecology. It's well beyond our expectations, the response we've got. So thank you all for taking the time. Me and Jeffro were involved in a survey last night, so we're kind of getting the ecologist experience as well of being a little bit tired in the morning. So appreciate all joining us, especially those who've been on surveys the night before. I'm just going to start the presentation now. I think I can still hear people coming in, but we'll get started. So yeah, we are Thermal Vision Ecology, and I say this is our first webinar. I'll just kind of go through what the order will be. So just start off introducing ourselves, tell you a little bit about what we do and how we kind of started, and then I'm going to spend a very brief amount of time on the basics of thermal imaging. We've got a lot to get through today and a lot to show you, so I won't spend too much time and I won't get too technical about that. Then going to discuss some of the advantages of thermal imaging, comparing it to scopes, and why the more advanced cameras are capable of more than video recording scopes. And then we'll talk about some of the software features that do differentiate our thermal imaging cameras from what else is on the market. And then after that, my colleague Jeffro is going to go through more of the what a hire kit would look like, what the journey of a hire is, and that should, well, I'm sure it won't answer all your questions, but we'll give you enough information there to kind of understand what we're about and what we provide. And then Liat, who's also kindly joined us, is going to add her expertise as an ecologist and a thermographer as well, and give her own presentation. So let's get started. So yeah, we are Thermal Vision Ecology. We were established earlier this year on the back of our other company, which is Thermal Vision Research. So our company is here to, we specialize in professional thermal imaging solutions for ecology surveys. And ourselves and Thermal Vision Research, our sister company, we are premium technical partners of FLIR, which means that we're contracted in the UK, one of only two distributors, and the only distributor that can supply their full range of research cameras. And FLIR, if you've not heard of them, are the industry leading manufacturer for thermal cameras worldwide. So if you've got a scope or you've got any experience with thermal imaging, you've probably heard of them. We started 10 years ago. My colleague, I joined 2 years ago with Thermal Vision Research, and the cameras were generally used for R&D, for research applications. But last year, we was invited to do an ecology survey, and the cameras, so we took our cameras, and although logistically it was quite difficult, the footage that we got and the software features that we applied to the footage was completely new and completely different to what the ecologists had seen before, and it kind of got us thinking. So what we've put together is a nice kit and some software features that will be right for ecologists to use on survey. So we're going to go into that in more detail. As well, we've got a lot of experience doing field and classroom-based training courses, and we'll talk a little bit more about that later. And we do purchase as well as rental options. And something we've always done with Thermal Vision Research is provided leading technical support throughout the lifetime of any product that you have. So if you ever got any questions or need support, we're always there to kind of help. To start with, we'll start with how thermal cameras actually work, and this is the most basic way to frame it. Really, as an ecologist, you don't really need to know too much about the technical ins and outs and what's happening with the camera. But on the most basic level, all objects emit infrared energy, and this is detected as heat. So the energy that's emitted by an object, in this case a bat in a diagram, is proportional to its temperature, and the lens in front of a sensor concentrates this onto a detector, and then the software maps each temperature or each intensity of infrared to a color on a palette, and that's how it works in its most basic form. The difference between infrared and thermal imaging, so technically all thermal imaging and IR are the same, it's just different parts of the spectrum. So The technology, I think, which is more common in ecology at the moment is shortwave infrared cameras. So these are your night vision and your IR, which require illumination, and they're in the 0.8 to 1 micrometers. The drawback with this is you're often restricted by the range because you need the illumination, and they're using reflected infrared, not actually looking at emitted heat. So our cameras work in the long wave infrared region where there is a large contrast in changes in heat, which means that we can visualize those, and we've got contrast. If something's hotter than its background or a different temperature to its surroundings, we can visualize that. So the advantages of this is that we actually have true night vision. So the image is unchanged whether it's dark or whether it's daylight, and there's no illumination required. They work the same. So they could look at birds during the day or bats at night, and it's exactly the same. And if you've got any big floodlights nearby, that's not going to interfere or saturate the camera like it might do with an IR camera. As well, what our cameras do, the FLIR cameras, is they record the radiometric data as well. So radiometric recordings are not just the thermal video, they contain temperature data for every pixel of every frame. And this allows for actual data manipulation. So I won't go into it too technically, but in simple terms, it means that we can change the things like the palette, the scale, and customize the thermal gradients within the image. And what this allows us to do is to do clever things like track and compare specific regions of interest. So if you're looking at a particular emergent spot, we can set up sections that will monitor that. And we can do things like flight tracking and image enhancement. So hopefully a lot of you have maybe seen some of the videos we've posted online in the last few months, and we'll go into those in a little bit more detail in the next few slides. So what we've done is, using the radiometric data and the software, is built a toolkit that ecologists can use, and we've streamlined it and simplified it so that you don't really need to understand exactly what's going on mathematically. These are just simple features that you can apply to your footage. So a lot of people, I understand, have been using the scopes, and FLIR do make very good scopes as well, and they're very portable and easy to use. However, they do have some drawbacks. They often have limited recording options, so recording a full survey on some scopes is not possible. They maybe only record in small chunks. And also with all scopes, the data that you get is just video, so it'll be MP4. So it's non-radiometric. And also as well, from speaking to a lot of you guys, you've mentioned that with scopes, often they have a long focal length, so you have to stand quite far back in order to fit in buildings. With fixed cameras that we have, they do require an external power supply and the PC to use. However, we've overcome and improved the setup by integrating the PC and the PSU into a single unit, and I'll show you a picture of the setup later. Sorry, can somebody who's got the mic on? Thank you. So this has improved the portability and usability, just making it a bit more practical in the field. And what the fixed cameras can do that we have is record and stream radiometric data as well, and they can do this for an indefinite duration. So as long as you've got the memory in the PC, it will just keep recording until you stop. They also come with a wide range of interchangeable lens options. So we have all these lens options available. So you've got the 6, the 14, the 24, 48 and the 80 degree. So this relates to the size of the aperture. And the 80 degree, which we've just used on a couple of surveys recently, has been really popular because you can get very close to a building and you get such a wide angle with it. It's proven, I think that would be quite a popular option. So this is what the kit looks like and what you get with it. You've got the FLIR A700 camera, which is an image streamer camera, and it has a resolution of 640 by 480. Again, you've got the lens options there that would come with a higher kit. And as you can see, this can be picked up as a single unit and moved about depending where you need it. It is designed to be left in the same place for a long period of time to capture, say, a particular feature that you're looking for. The kit does come with the tablet and with the software needed to use it as well. The tripod is very heavy duty, so you can use that on quite uneven surfaces. And the battery power supply is incorporated, attached to the tripod there, so it all can be moved in a single unit. And it takes about 5-10 minutes, maybe less, to actually set up. So these are some of the features which I think we're most interested in. This is the exciting bit. Some of you may have seen these, but some of you may not. This should be able to play. So what we can do with the radiometric data, this is a technique called image stacking, and it will, every maximum temperature, it will hold that pixel value, which means if something's hot and is traveling across the screen, like so, it will have the effect of tracking the flight of the bat. So you can see these are identical videos with the filter applied, and you can see very pretty shapes that the bats make there. If you look closely, you'll see as well that there are bats inside the church, and if you miss it first time, or if you don't see it on the video, it will leave its mark on the on our with a flight tracking feature, and you can, even if you miss it in real time, it will leave an imprint there, so you can just see the faintest little dots where the bats have flying about the church. So this is one feature that we can do, and it can be applied in real time or after, when you get your recording back as well. And I'll do a quick demonstration in a minute to show how easy that is. Oh, that's playing again. Don't want to do that. Okay, this is another feature that we can do with our cameras, and this is a track and detect. So this is one of the early surveys we did with Richard Crompton. I'm not sure if he's on the webinar, but I should say thank you to him, because he supported us a lot, especially at the beginning, and helping us kind of set up these filming opportunities. So what we've done here, on the left hand side, you can see we've put a box around the roof of this church, and what we've done is tracked the maximum temperature within that box. So if something hotter appears in the background, it will produce a spike. So on the right hand side, you can see here you've got the baseline noise of the temperature of the building. So this is just the internal noise of the camera and the building cooling over time. But we can see, first off, we've got this huge spike, so that would tell me that something has happened. We've got another one here and a little one here. So if I was reviewing this footage after I'd done a survey, you can correct me if I'm wrong later, but what we would envisage is that you would drag this slider along to each event and be able to see what it is. Obviously, not everyone will be an emergence, some may be false positives, but what it will mean is that there's a lot of dead time that you can skip through. So yeah, that's just a closer look there. So we've got event 1, event 2, and event 3. So look at this plot. They're 3 events that I might investigate. And if we look at the first event, I've also applied the tracking filter here as well. So anything that happens, we do get the flight tracking. So if we play this video, this will be the emergence. And as we can see, we've got that there. And in the software, you could extract that either as a short video or as a JPEG. So I'll just play that again in case anyone missed it. So that captured that emergence there. I was going to do that again. This is event 2, and we can see what happened here. So with this, right, we see there that the bat has flown into the area. The area is not being placed on the video. That's just, I forgot to do the checkbox to include that, but you can choose to include the regions of interest that you've selected or to exclude them. In this case, I've just realized I haven't, but the second spike would have been caused by this bat coming down and leaving the box again. This is event 3, so that's that smaller spike at the end, and I suspect that this will be something similar. So yeah, the bat comes down again, just drifts into the box and flies away. But from the point of view of an ecologist, maybe if you just see it leaving near the roof, you might suspect that to be emergence. But with our tracking technology, you can see that it's the flight path has come from elsewhere and it's not an emergence. And you can say, do this. We would recommend you probably do this after your survey in the morning or afternoon. Go through the footage and do it like this, so you don't have to be paying full attention or worried if you miss anything in real time. This is another feature we can do. So this one, it's probably a bit more advanced. It's no more harder to implement, but it's maybe take a little bit of explaining. So what this is doing is rather than taking well, I'll start from the beginning. So when I showed this feature originally, it was very well received, but one question that came up, which was very valid, which is, what if the building has been warmed up all day and the bat is a very similar temperature or maybe even a lower temperature than the wall behind it. So this feature is something that will solve that problem. So with this, it doesn't look at the maximum temperature, it looks at the difference in temperature. So it will take an image and subtract. So every image you see has been subtracted from the previous image. So it means any relative differences we see, and this makes it very sensitive, and it means that the bat doesn't need to be hotter than the background. So I'll play the video and you will see. So again, they're side by side the same video, but you will see in the background these flight paths that are not actually visible on the right hand side. So this means, I mean, these bats are probably, judging by the fact that they're maybe only a pixel in size, these are probably getting on for about 100 meters away or more, these bats. So it means if you're doing a survey and you're within, I don't know, typically maybe 20, 30, 40, 50 meters, if there's a bat there, we will see it, no matter what the temperature is of the building or how small the bat is, or if it's hidden quite well, we will see it. As you can see here, the closer bats show up even clearer. Video is a bit longer than I thought, actually, so I think you get the point with that one. So yeah, we can detect these any kind of faint trace of a bat, even though, so on a normal scope, a high-end scope, you would probably get the same image what you get on the right hand side, but with the software features, it brings out much more information from the image. Yeah, that's kind of what I spoke about there. This is taking it a step further. So this is combining the tracking, the event detection with the spikes, and also the subtraction technique. So in this video, on the top you have, sorry, on the bottom left you've got the normal thermal image that you would see, and I've done the detect feature, which is tracking the maximum temperature, and you've got a couple of spikes there that you might investigate, but there's a lot of noise. So if you was just relying on the maximum temperature, you might miss something, whereas with the subtraction you've got these extra peaks here, which are suggesting maybe more activity is going on than you see here. So I'll play the video through and you'll see as the grey line, it might be difficult to see over Teams with a quality reduction, but there's a grey line sliding along here, and as it hits the peaks, you will see the bats appear. So it's only in this area that I'm looking. So you'll see bats maybe appear outside of it. There won't be a peak, but any bat that appears within this area will show a peak on here. So I'll just let that play through and you'll see here. So we're coming to another area of activity. And there you go. And what you won't see is when there isn't any noticeable spikes, you won't see any activity either. So this gives us confidence that combining these techniques, we can we can see anything. If there's a bat there, we will see it. So this kind of sensitivity might not be required for most surveys, but the ability is there if need be, and it is just a couple of clicks. So what I'm going to do now is come out of here, and I'm going to just share the actual software. If I can find the right button for it. So now you should see a big FLIR logo on there. So I'm going to try simulate what the process might be if you're say you've done your recording the night before, you're back at home and you're opening up the files that you just recorded. So if we click on this bar, we've got the most recent recordings we've done. In this case, I'm going to use this one as an example. Thanks, Liat, for providing the footage for this. So here, I'll just remove that. So I'll go right to the beginning. So this is the footage here. You can see there's a lot of activity, bats through the windows here, but it's quite difficult to track exactly what's going on. Is there any against the wall? They're a similar temperature to the wall, but you might be interested in a specific area. So for example, if I just pause that, go to the beginning, we can get a rectangle or whichever shape you want. So if we just move that and say we're looking at which ones are leaving. I mean, this is quite a busy video. We probably won't be as busy in real life. It's an exaggerated example just so we can quickly see examples. So we draw the box there, and then we add the filters that we want to see. So if we add the max frame interval, so this is where we get the tails, and this will tell us how many frames we want to see. So how long do we want to see that? It doesn't really matter. I usually go for about 5, and we can do that. And then we need to apply the subtraction one, and that's the sliding subtraction, and we set that to the same amount as well, the same amount of frames, so it doesn't override it. And when we play now, you suddenly see actual flight paths of the bats within. And if I stop that, what I was going to do was just try finally to see if we can track those through there. So there's just one extra filter that reduces noise. It actually makes the image slightly worse, but when you're doing the analysis, you can turn it on and then turn it off again. So I'm just going to do, oh, not that one, the window average. So we'll make it a little bit fuzzier, but what we do is we can do a temporal plot of that rectangle, and we plot the maximum again. So it's plotting the maximum difference in there, and we can put that, choose where we have that. And if something flies through it, so here we go, we've got all these spikes here where I'm pretty sure that's where bats are flying through. So I'll just let that. You're best off just letting this process. If you've got a lot of footage, it might take 5-10 minutes, but it's kind of, you can go away and leave that running. And then now if we can turn that other filter off this one because it does make it a little bit muddy. If we play it, we should see every time we get the spike, there should be a bat going through that area. Fingers crossed. And there we go. You can see one just the edge of a close one was just grazing the edge there. If we go to the next one, I'm doing this very quick. There's other little parameters you can change to increase the sensitivity and other little tricks, but I'm just trying to show you in a very the most straightforward that is for someone not seeing this before. But you can see every time a bat goes through, you see that. So if I slide that to here, so quite busy there. So every time that goes through, you'll see a bat on there. So that's detecting every time there is a difference in the area there. So I'll stop that now. I'm trying to be conscious of time as well. So I think it's you now, isn't it, Jeffro? I think so. If I stop sharing this and go back to the presentation. Are you there, Jeffro?
Yeah, just waiting for the presentation to come up.
That's all right. Sorry, yeah, I can't see anybody at the moment, so I'm a bit blind at the moment. Assume everybody's there and mostly listening. Right, so yeah, so Jeffro's our business development manager, and he's been helping put the kit together and sort out what a hire package would look like. So Jeffro's going to talk you through what that is. So I think you start here. There you go, Jeffro.
Brilliant. Cheers, Andy. Yeah, I'd firstly just like to start by thanking everyone for choosing to spend this hour with us today. I'm sure many of you were on surveys last night, and obviously it's right in the thick of bat season, so we do appreciate you attending this webinar. I'd just like to start off with some kind of technical specifications of the main camera that we'll be renting out when you rent the Ecology Kit. That's the FLIR A700 Science Kit. So if we look at the resolution 640 by 480, that's very comparable to a lot of the scopes that you will be purchasing. Of course, as Andy's just gone through, you get the software, which you perhaps won't with the scopes, but the resolution is very similar. Next up, we'll go to the frame rate. So that's 30 hertz, which is more than enough to be able to track bats at quite some distance. I mean, even last night, I think Andy mentioned at the start of this presentation, we were actually out in the field as well, helping with a survey. And by using some of the features, we were actually able to detect bats at easily 80 meters, if not more. So it's really solid, and the frame rate was holding up nicely. We've also got several different lens options. So we've got the 6 degree, which will help you see higher quality at a further distance, all the way up to the 80 degree lens, which is going to be an ultra wide field of view. And you can still get accuracy to about 40 or 50 meters away. So that's a really great lens, especially if you're measuring a big long wall, big side for building. You know, the 80 degree lens is a solid option. Just a bit on the exportable formats as well. As you see, there's JPEG, PNG, MP4, CSV, as well as all of the radiometric data that you get within FLIR Research Studio. So you've got many options. If you needed to include a snapshot in your reports, for example, it's so easy to just export a JPEG or, you know, an MP4. Yeah, cheers, Andy. Next slide. Now, with the different lenses, obviously, if you've never used the cameras before, you've never used the different lenses, you're probably thinking, well, what lens do I actually need? Fortunately, FLIR provide a kind of lens selection viewfinder on their website, which will include the link in the descriptions of the recording, and maybe we can pop it in the chat here as well. But what I've included on the right-hand side is just a standard example if you're using the 24 degree lens, and you can see the different distances all the way from 1 meter up to 100 meters. Now, the two fields next to it are horizontal field of view and vertical. So you can see, you know, at a distance of 10 meters, you're going to get like 4.5 by 3.3, which, you know, it can really help to just inform which lens you actually need to use. And after a little while, you'll get a kind of a natural feeling for what lens you need for what survey. But as you're getting into it, maybe your first few rentals, it's a really solid option to just be able to have a look at this lens selection and, you know, take it from there. Yeah, Andy, next slide. So Andy showed what the kit looks like when it's all set up in the field. I've just got a little slide here to show you how you're actually going to receive the kit. So we've got these big newer flight cases, as you can see, and everything fits really neatly inside. I mean, once you know what you're doing, it doesn't take any more than 5 minutes to get this all set up. As you can see, you'll have the tripod, you'll have the tablet, battery, cables, everything included. And if you've got more lenses, then they all easily fit in there as well. So it's quite an important consideration for us, like how you guys are actually going to use this in the field. When we started, we certainly didn't have these cases. We had a few separate bags, and we got some feedback. You know, it's not ideal when you're dragging them along big fields, like grassy terrain. You want something a bit more sturdy. So these have wheels. They're easy to carry along, and it's not too heavy either. I think we weighed it the other day. It comes in at about 17 kilograms. So it's not the lightest thing, but also, you know, it is what it is. You've got a big tripod in there. So I think this is the best solution we've got.
Yeah. I would just, sorry, Jeff, I would just add that the most of the weight is if we have a choice of a Jackery battery as well, which is a bigger, heavy duty one, and that adds a lot of the weight. So if it is a bit heavy and you have to carry it far, you can maybe not do without the big Jackery battery. With a smaller battery, which we provide, the survey, you can do a conductor full survey with that. The Jackery is more for topping up if you need to, if you're doing a couple of surveys consecutively, or you need to charge your laptop. But yeah, sorry, Jeffro.
Yeah, no, I've actually got an example of the smaller battery here. As you can see, it is quite small, and about 2 hours of recording only takes. Oh, can you not see me on the video? Never mind. We'll skip that. But the battery's quite small. It's maybe 20 centimeters, and it only uses about 20% of charge for 2 hours. So it's a nice lightweight alternative to the Jackery.
Yeah. It fits inside the bag in the top right of the thing that was kind of exemplified.
Yeah. Next slide, please, Andy. Yeah, no, I'd just like you to walk you through kind of the logistics of hiring, what that actually looks like, and how you're going to get a hold of the kit and actually do the survey. So we've got a couple of options. If you're nearby to Bristol, then it may be an easier option for you to come into the office. We'll have the kit all ready, and you can pick it up and then obviously take it out to your survey that evening. We'll also be able to provide the in-person training just to show you how to set everything up and walk you through a few of the software features which Andy just walked you through as well. So that's one option. Alternatively, if you're further afield, we can definitely deliver. It will come in the flight case that I just showed you, and that will also have a return label, so we can, it's quite a smooth process. We can do next day delivery. So that's kind of how you'll get your kit. And yeah, we'll provide a free training session. And if you are getting it delivered, if you're further afield, we can do that same training session just over a Teams call, Google Meet, whatever you prefer, just to make sure you're kind of not going into the field blind and you've got some good notes to work from. Additionally, we also include a laminate printout in every flight case, which just walks you through where you need to put what cable and how to set everything up. So we've done our best there to make sure it's quite an easy setup. But, if you ever run into any troubles, we're only a message away. Yeah, next point, on-site attendance can be arranged and recommended for the first time. So with the on-site attendance, you'll get either myself, Andy, or Liat, or maybe all three if you're lucky. And we'll just walk you through setting everything up. We'll bring additional lenses, and we'll really make sure that the whole night goes without a hitch. If there's potentially any technical issues, or maybe it's not worked with your computer or tablet, it's probably an issue we've run into before, so we can definitely help and smooth things out that way. Now, it's happened a few times already, but we know the weather can disrupt surveys, and it happens last minute, and you kind of make a call on the day. We fully understand that. We're not going to penalize you for that. You can rearrange, so if it's going to be rained off in the morning, just give us a message, rearrange for another date, and you won't have to pay any more. We can just rearrange that. The one kind of caveat to that is if you have already collected the kit and you're out in the field and maybe it's like 7 p.m. and then it starts raining, you won't be able to rearrange that, but we will certainly look to how we can kind of come to a good deal there to make sure you're not too put out. But next one is grouping thermal appropriate surveys for cost efficiency. Now, of course, you guys are free to kind of approach how and when you'll hire these kits by yourself. But we found quite a good approach is if you have several buildings or several surveys where you're thinking, this thermal kit could be really useful. If at all possible, group them all within a week, and then you can just hire the kit out for a week. You'll receive a nice discount for that as well. And it just means we're not having to post things back and forth. You've got the kit for a solid week, and you can just do all your surveys, and that's probably quite a convenient way to do things. There's also the option of having a seasonal hire, which is, as it sounds, you can rent it for 1, 2, 3, 4 months if you so wish, and it just provides that same convenience, and you're not having to constantly think about where the kit's going to be and when access to it. Yeah, next slide, please, Andy. And this is the prices, essentially. So ecologists do receive an introductory discounted rate. That's something that we're running for this first season, as we are quite new to it, and we wanted to make sure people can get it into their hands and see whether or not they think it's a good idea to move forward and hire in the future. So to support that, we have given a 50% discount. Typically, renting out a FLIR A700 would cost £155 a day. We've discounted that down to 75, and as you can see, similar for a week and a month, £350 and £1,100. So we're really doing the best we can here to make it a cost-effective solution. We realise in the past, thermal has been quite an expensive option, and which is probably one of the key reasons a lot of ecologists haven't really gone for thermal imaging, but we're doing our best to kind of counteract that. Yeah, next slide, please. Yeah, just the final slide from me is kind of what we're going to be doing over the next few months. So Hesticombe, 13th of August. This initially started as we're going down to get some good content for our social media, test the kit out. As you can see, there's a picture there. It's a lovely site just down in Taunton. And what we'd like to do is that there are limited places, but if you wanted to come along and kind of see the kit for yourself, get a chance to use it, there's loads of bats at Hesticombe. We'd happily invite you along. Again, it's down in Taunton, so I appreciate a lot of you probably couldn't make that, but if you're local, if you're in the area, more than welcome to come along and try out the kit for yourself. Next would be the National Bat Conference, 13th to 15th of September. We'll be there across both days. We'll be running a workshop with the kits, showing everyone how to use it. If you're attending, please pop by. We'd be happy to have a chat with you. As I said, we're there for both days, so it would be great to kind of meet some of you guys and see what you think face to face. And then I think the final note from me before I pass over to Liat would be as kind of a thank you for everyone showing up to this webinar. If you do want to hire the Ecology Kit, even if it's just for a week or so, we have included a promo code on our website. So if you just pop in TVR10 when you're doing a booking inquiry through the website, we'll give you an additional 10% off on any week-long hires. Now, that is limited to the end of this week, so by the time Saturday rolls around, the promo code won't work, but any inquiries before Saturday, and we'll honour that, and you'll essentially be getting a 60% discount on the price of the kit to rent. So, do with that. Cool. I'll pass on to Liat then. Liat's I'm sure some of you know Liat. She's a very seasoned ecologist, and she's used thermal imaging solutions for quite some time as well. So she really knows what she's talking about. And yeah, thank you.
Sorry, Lee, just before you start, I've just seen there's a few questions popping up in the chat. So what we'll do is we'll go through these at the end. It was scheduled for an hour, but I'm happy to stay on the call. And Jeffro is, I think Liat might need to get off. I think you've got a survey to do, but we can stay on, try and answer as many questions as we can. So yeah, thanks, Liat, if you go.
Okay, let's present this. Okay, can everybody see my screen and hear me okay?
We can see that, yep, Liat.
Yeah, good, okay, great. So thanks, Andrew and Jethro, for that presentation and also inviting me to speak from an ecologist perspective, not so much a technical or software developer's perspective, but it's a rapidly developing area of our work. And I'm hoping, like me, when I first saw what this software can do, you're all quite excited about these developments. So I'm going to give a very brief talk on sort of thermal imaging and ecology surveys, focusing on bat surveys. And it'll be an overview of my experience using this technology over the last 10 years. I started really when there was no focus training, there was no guidelines, there was no sort of standardized methodology. And the ecologists that were using the technology way back then, there were a few of us. It was really learning by trial and error. And it did teach us quite a lot about the limitations, but also the benefits of using thermal imaging. So I'll go brief introduction to me. We'll talk about field applications, then thermal kit selection, and some issues to be aware of. I might touch on a few things that Andrew also touched on, so I'll kind of speed up those slides a little bit, but I'm around for some questions, or if you have any questions from an ecology perspective, then do email me or leave the questions with Andrew and Jethro, and I'll be able to answer them later on. So I'm Director of Sonar Ecology. I've got a research background, and my PhD was on bats many moons ago now. So I'm a bat specialist, and when I first entered the world of consultancy, that's obviously what I did most days and nights. And I used to get really frustrated with the heard not seen entry in my bat survey forms, which I'm sure all of you do as well. All of that activity, as soon as the light fades, all of that activity above your head, you've got all the acoustic information, but you can't see anything. You don't know what the bat's doing. Is it one bat? Is it 10 bats? Where are they going to? How are they using the habitat? It was immensely frustrating. And the first time I used night vision aids, as we now call them, which include reflected infrared, was back in 2006, and that was a consumer product. It was a Sony Night Shot camcorder, which I hooked up to a motorbike battery and put a infrared filter on top of a Clue light, and it was all very Blue Peter, but it worked, and I got some good images. But again, it didn't really answer my questions. Bat counts in and out of roost, that was no problem, but understanding how bats were using the landscape, the habitats, and the wider environment, that was more tricky. And that was purely because, you know, it was reliant on illumination, infrared illumination. And I know now the illuminators you can get are very powerful, and there's way more on the market than there was back then. So your range is better, but you're still limited in what you can do. I first used thermal sort of coming up to 10 years ago now, and I invested, or my company invested, in a FLIR handheld camera, and it was a real eye-opener. Like I say, there was no training. I struggled to work the camera because it's very advanced. So I looked for what was out there, and I did the certification from the Infrared Training Centre, which was more geared to research and development and industry, not really ecology at all. But it did give me a good grounding in the basic thermal science, which is important to understand when you're using kits like this. So it's since then it's been my workhorse. I use it on every bat survey. I also use scopes now, and there's a big difference between the two. And I know Andrew touched on that, and I'll go into that in a little bit more detail later on. So apart from ecology surveys, I also do a bit of research on the side when I get the time, which is not as often as I'd like. I've been a thermal camera operator for TV documentaries and advised BBC on the application of thermal imaging within ecology. I'm also trained in the use of thermal imaging in veterinary medicine, assisting diagnosis. It's a very exciting field, yeah, there's so many applications, but we'll go on to some of the broader applications now. So the first one is sort of remote sensing. It's the bread and butter of what we do as ecologists. So it's detecting presence or absence of a species or a population. But there are also other applications within wider ecology and conservation. Incidentally, in conservation and sort of wildlife conservation internationally, thermal imaging has been used for way longer than we have been using it within consultancy. And I'll touch on that a little bit later. So you can also look at the condition or status of an animal, breeding condition, stress levels of animals in captivity. So you're looking at health. This top right image is the hind limbs of a horse. In the equine world, thermal imaging is used and has been used for a very long time to look at health issues. So before an injury happens within an animal, you can detect changes, physiological changes, which is obviously reflected in surface blood flow, temperature, which is what thermal camera can detect. So you can really pick up issues, health issues, whether it's lameness, inflammation, early onset of disease. And if you think about, you know, horse racing, it's a huge industry, lots of money in it, and the health of your animal is key when it comes to performance. So that's a big area of application. And then we go on to monitoring. So for our work, it's a lot of pre-development, post-development, baseline data gathering. We can look at you know, the effectiveness of mitigation measures that you've put in place, behavioural studies, all animals, including us, when we're stressed, we have a different surface blood flow pattern. You know, it's a physiological change within us, and that can be detected by a camera. So a lot of zoos use thermal imaging to check the stress levels of their animals and look at the behaviour changes within you know, an enclosure if they're making any changes. The last two bottom right images, it's the top of a rainforest canopy. This study was done quite a long time ago, so 2018, I think. Dr. Claire Burke used drones with thermal imaging cameras attached to them to study orangutan populations. So again, doing it before this technology came about, you'd be on the ground looking up, and it's very difficult to see. They're quite cryptic. You don't know really what the population's doing, the group dynamics, but using thermal imaging at this height, also with deep machine learning to identify the type of animal through their thermal, sort of what we call thermal fingerprint, was revolutionary in how to sort of monitor wildlife and study wildlife remotely. So on to a few more applications that we are more familiar with as ecological consultants. The application is kind of increasing with more ground testing, I think, but I've certainly used it for nesting birds. I know a lot of bird groups and wildlife groups use thermal imaging now and scopes to undertake and aid their ground nesting bird surveys. I use it to check for nesting birds within hedgerows and tree canopies. You need to be aware of, the environmental conditions. So on a super hot day, this top left-hand image is tree canopy. You've got a big nest up here. You can't see my mouse. I'm just aware of that now, but there's a blob there. Everything's the same temperature. It was a hot day. On days like that, it's almost ineffective to look at to see if a nest is active or not. But if you have a cooler day, you will note even from below, from ground level, if a nest has got eggs in it, if the bird has flown whilst you're observing it. Other things you can apply thermal imaging to, badger monitoring, for example, looking at group dynamics, habitat use. But obviously, our key focus for today is bat surveys. So we often do a pre-development baseline data gathering exercise, and that's through our emergence and re-entry surveys, habitat use, and crossing point surveys. So where you've got linear habitats that are going to be fragmented or severed, thermal imaging cameras are brilliant for looking at that, the actual flight paths. And I know sort of if you've got Andrew's presentation in your head still, that flight tracking ability is really quite revolutionary for what we would want to look at. So height of the bat flying above the ground, exactly how they're using that linear feature. If you're in a woodland, you want to see how different species are perhaps using different levels within the canopy. That's all possible now using this kind of processing power. And then you've got your post-development monitoring as well. So changes in habitat use. Are animals behaving the same way as before to an impact? All of that can be done or aided with thermal imaging. Bat box checks. You can't really tell if it's a bat in there, but you can certainly tell if a box is being used. So this little Schwegler box in the top right hand corner, it's got a hot spot at the top there. That's the heat generated by, or emitted, sorry, by one pipistrelle. So that was a pip warming up just before emergence. So I like to do a quick check with the camera just to see if there's anything in the box or not. Sometimes it's a bat, and often it's not a bat, it's something completely different. So here, this bottom right is a hibernation box. And if you know these boxes, they're heavy, they're thick, they're really well insulated. And I looked at this with the camera and thought, I don't know what that is, but it's not a colony of bats, I don't think. And it was a huge hornet's nest. So again, I've said health and safety at the bottom of this list, but before you climb a tree and pop your endoscope in anything, then it's quite nice to know that you're there's going to be something in there. It might not be very friendly either. This series of 4 images was quite interesting. So the top left, where I've got the circle, it was a really big oak, and that was taken with the camera quite far away, and there was a really clear hotspot on the main limb. And closer there was a woodpecker hole. I was got quite excited thinking it was a nocturnal roost, but it turned out to be a massive bee's nest. So before any tree climber goes up there, it's important to know what you're looking at. So it can be quite handy in that way. So going into thermal imaging equipment, it's a bit of a minefield. It's probably the question I get most commonly asked is what should I go for? What scope should I go for? What camera should I go for? None of them are specifically designed for our applications, and that's quite important to realise. They're all really designed for research and development or condition monitoring and fault finding in industry. And when you're talking about scopes, they're primarily designed for hunting or game spotting at quite a long distance. The thermal imaging survey guidelines for bats that were updated, I think, in 2021, they do list, it's full of information there, definitely. I'm sure you all have read them, but they list the key specifications. So you've got suitable resolution. I think the minimum is about 320 by 240. Higher is better, and I think standard now is about 640 by 480 pixels resolution. Thermal sensitivity, which sometimes is on any sort of spec sheet of equipment, it might be described as NETD, noise equivalent temperature difference. It's the measure of how sensitive the detector is, and it's measured in millikelvin. So the lower that value, the higher the sensitivity. And that's important when you're trying to detect a very small target that's moving. And then frame rate. Obviously, that's how many still frames is recorded within a second. So the higher the frame rate, the smoother your footage will be. But it's also important to know that, less than 30 frames per second, you are likely to completely miss a bat, because they're very fast flying animals. So as I mentioned, scopes are designed for, they have a generally a narrow field of view. And I know a lot of you, I myself have one, we are limited sometimes on site as to the distance we can get back from our target. And that's a limitation to be aware of. You either need to have multiple scopes or, a camera or varying lens options. And scopes often are fixed lenses. You don't have the ability to interchange those lenses. There are models where you have different lenses, but then you'd need a range of scopes. So it's always a trade-off. And the big difference between a scope and the cameras that Andrew was talking about, and the camera that I also sometimes use, is in its output. So he mentioned radiometric data, and we'll just go on to show you the difference really with some examples. Okay, so a radiometric file has that temperature information embedded into each pixel. So it allows the analysis and thermal tuning to bring out the details, but not just. So if you're looking at just a JPEG, which is not radiometric, you can manipulate that image to a degree. So you can, increase the contrast, but you're increasing that contrast across that entire scene. You can't pull out information just on the bats, and that's where the radiometric image is very powerful, because you can. So the pros to that kind of data outputs, accuracy, obviously your ability to adapt those images and videos later on. You can get apparent temperature information, which might be important if you're doing research or depending on your project. And obviously highlight new development in post-processing and analysis is you can actually have a more efficient workflow. The cons, obviously these files are huge. They're very memory intensive. You need high capacity drives and power sources, and your backup system needs to be powerful and large. So, our field is becoming increasingly technical, and all our peripherals, from laptops to computers to hard drives to backup, all sort of mounting up. Improve with this, but that's what you do need to be able to have an efficient workflow. So just to reiterate, MP4 files, the movie files, your standard MPEG, AVI files that scopes will output, they're not radiometric, they don't hold any temperature information, and therefore they can only be manipulated visually. The images just shows you some hibernating lesser horseshoes hanging from a shelf, and with the radiometric JPEG, I can put a spot on each bat and the shelf, and you can just pull that temperature information out, which is important if you're looking at some research. If you're looking to see if those bats are being aroused by any disturbance, then they will start to warm up. Speaking of, this is another, just an example of the power of a radiometric file. It shows, if I play this, a common pipistrelle that's warming up from daytime torpor. So it will arouse using a process called thermogenesis of brown fat that's concentrated between the bat shoulder blades. So using a dynamic radiometric video, you can see where the thermogenesis started, how that heat dissipates throughout the bat's body. It's increasingly getting more active, and its ears are twitching, starting to echolocate, and then it will eventually fly off when it reaches flight temperature. So all of that, you can then pull out temperature information. So this is just an example. We don't need this in our day-to-day work, but it's just an example of the power of a radiometric image. So I'm just going to briefly go through issues to be aware of, which will include the impact of certain environmental variables on your thermal image, kit selection points, and analysis time. So both scopes and cameras rely on thermal contrast between your target and the background. So the ability to distinguish detail and for the camera to focus is affected by environmental variables. Two key ones are your ambient temperature and relative humidity. So this top left-hand image here shows a woodland ride. It was a really hot summer's day. And as you can see, the tree trunks are glowing pretty hot. So on a hot day like this, the heat of the day will affect your image at night. So the radiation that falls on any potential target subjects like a tree trunk or a roof or a wall, these structures will emit that heat absorbed during the day, during the night. And this image will probably look similar for a good few hours. It's by dawn that the trees will cool down enough to have, a flatter image. So if you can imagine yourself sitting there trying to look at a feature like a PRF on one of these tree trunks, it's going to be very difficult. You will detect the bat, but you might not be able to track back to where the bat actually emerged from, which feature it emerged from. And if you can try and project that onto, say, a hot roof or a hot wall, again, Andrew showed some filters using that software where you could be able to extract exactly that information you need. But if you're unable to do that just by using our eyes, it would be almost impossible. So this top right image is another woodland. It was a much cooler day, and you can see the people are standing out very clearly. Any bat emerging from any of the trees would be very clear too. So there's the difference there. High humidity as well. Atmospheric moisture can introduce noise into a scene, making it look very grainy, a bit like an old film camera. An old film print. It's a similar kind of issue. And because the image is very flat, the camera or scope will be very difficult to focus. And I don't know, probably many of you have come into this problem using your devices in the field. A similar effect is seen in very cold conditions. And this bottom image here shows there's actually a hibernating bat at point SP1 in between two bricks. And my camera just would not operate properly. It just wouldn't do anything until I put my finger on the brick next to the bat and left it there for a couple of seconds. And then it left a thermal fingerprint there. And my camera was then able to focus on the scene because there was some thermal contrast. So it's just an example, but it would be the same kind of image that you get within, if it rained all day and you're out doing your dusk, the scene would be very grainy and you'd find it very difficult to pull focus. So these are just issues to be aware of. Kit selection, I'll speed through this bit because I'm aware of time. So have you got the right thermal device for the job? Have you got the correct lens and field of view for your job? And your detection range is quite key. So this first image, again, I would never have been able to get that entire angle of building. It's a complex roof void. With a scope, I'd have to stand way back or use multiple scopes. So it's really looking at your project, looking at your building, your tree, your situation, and the questions you need to answer, your budget that's available to you, the kit you have available to you, or what's available to hire, for example, and really tailoring it to what you need. So this is the bit that I think is really quite a game changer in terms of what Andrew and his team are doing. The software that we've looked at through the previous talk was Research Studio, and it's dedicated to FLIR cameras. So obviously, if you don't have a FLIR camera, then that is something that you now can hire rather than buy, because they were prohibitively expensive. Scopes, more affordable, but obviously we talked about the downsides in terms of the output. It's not radiometric, and therefore you can't manipulate the information so much. When you're reviewing scope footage, it's a movie file, so you can just play it on any media player, of VLC media player, for example, or Windows. But I've used software called DaVinci Resolve, which is a free software, which is a kind of a semi-professional video editing software. And I use that with a jog wheel to be able to go forward frame by frame, which is quite critical. And that's why frame rate's important, because even with a high frame rate, depending on your peripherals and the speed of your SD card, for example, you can get drop frames on playback, and there's nothing more frustrating than having a bat suddenly appear and you can't track it back because that frame's been dropped or missed. Of the software that Andrew demoed is quite key, because at the moment we're doing this all very manually. You need to be playing footage back real time or close to real time, with the ability to reverse and fast forward frame by frame, particularly when you're working with MP4 files. So the massive advantage with the Research Studio software is that will automatically run through hours of footage in a few minutes, and it'll pull out those thermal events for you, and each event will be time stamped or frame stamped, and then you can go back and look at it. And I know you understand the pain of going through hours of footage. You can't, you're knackered anyway from a bat survey, or you've got lots of other things to do, but you really need your full focus on playback, because otherwise you may miss an event. So this takes out all of that human error. It's automated, and it really is, I think, a game changer in how we can analyze our hours of footage. I will end there. I'll play this video that I only put it in because it's fun. As soon as I learned about the filter, I applied it to a maternity roost. But I hope you can have a look at this and then just see the kind of projects that you might be able to use it on. For example, like a post-development monitoring of, I don't know, onshore wind turbines, so you can actually see the impact of the turbine and how bats are flying in relation to that structure. We can better understand how bats are using habitats at risk of fragmentation or severance, and therefore then be able to better design more effective mitigation. So I hope that's been helpful, and I'll end that there.
Thank you, Liat. That's yeah, you certainly had a lot more expertise than we can as an ecologist. As I see in your video, it's the first time I've seen it shared back. So in real time, without it being streamed on Teams, the flight paths are incredibly smooth. Say it's 30 frames a second, but there's a lag or a reduction in frame rate were created by Teams. So now it's well, we finished a little bit later than expected, but I think that happens every time we do something like this. But if there is any questions, I've tried to answer some as I've gone through the chat. If people want to type in their question, I'm quite happy for someone to put there's a raise hand function if someone wants to raise their hand and ask a question over the mic. So Steph Harper, is that so? Yeah, if you can turn on your mic, please. Yeah.
Yeah, hi. That was all really brilliant information. Thank you. Liat, how much time do you need the next day for processing the footage using the filter with or various analysis packages to just work out where the bats are coming from, or what would you allow as a rule of thumb generally?
Using the software that Andrew demoed?
Yeah.
Yeah, I haven't fully run through a complete survey, but from the footage that I have used it on, because you can highlight a region of interest, which is also quite key. So if you're just looking at emergence, you don't really want to know, it's important anecdotal evidence for bats flying overhead and coming from different places. But you can almost run two sweeps of analysis. So for the emergence, you can do your region of interest, a rectangle or whatever shape, across the eaves of a building, for example, or the ridge of a building roof. And I think, I mean, Andrew, you might be better placed to know how fast it will take to go through, say, an hour and a half of footage. But certainly for sort of 10 minutes, it's only taken less than a minute for the sort of filter to sweep through.
Yeah, so I would say it depends on the how much activity is going on. So the video I showed, which was short, was really just to show like an exaggerated version. But the previous video I showed with the event detection, that was one emergence in a hour and a half, 2 hours of filming. So if you had to analyze that yourself and watch it through, it would take you, well, even if you sped it up, maybe it's going to take you an hour at least, maybe more. With hours, with those spikes, that would be reduced down to minutes in that particular instant. You would go to each spike, analyze each spike. Now, if you've got a lot of false positives, it will take longer because you've got more spikes to investigate. But the fact that you can cut out that dead time in between, so you don't have to watch the whole thing. So there's no fast rule to say it will save you this much time, but it will. I would say the less that's happening, the more time it will save you. For example, if you're looking at a particular feature and there is no activity or evening, you will get no spikes. You press you set the temporal plot up. It will take about 5-10 minutes for the computer to process it. It will give you a plot, and if there's no spikes there, you can say there was no emergence from that building during the time that the camera was there. So it depends how much activity there is. If there's no activity, it saves you all the time. If the more activity there is, it will save you less, but it's telling you exactly where to go where something's happening. So it's just cutting out all that dead time in between. It would be good as people use the kit. We are asking for feedback to see how much time it does save them typically. But I hope that kind of answers your question for now, Steph.
Thank you.
Yeah, if there are any other questions, just click the raise button on the top toolbar, the little hand. There's a few questions in the chat there as well. I don't know if Jeffro can help with that. So, Sean, yeah, if you just want to turn your mic off.
Yeah, I was just interested whether you can draw multiple features of interest in one sweep, or whether you would have to run it multiple times, so multiple boxes.
Oh, right. That's something I maybe should have showed actually. Yep. So you can do multiple boxes and you can plot them on the same graph. So there wasn't, well, it would say there's a lot to fit in, but there is a demonstration we do where on that same one where we highlight both roofs on the church and do the same analysis, and you end up with two different color graphs alongside each other, and you can differentiate between the spikes on each one. So where a bat has flown through both areas, you can it's gone through one but not the other, you'll get a spike on one and not the other. So that might help determine whether something is emergence, because you can say, well, if it's come from above that box at the same time it's gone through there, it's not emerged. However, if it's come from the bottom box and not passed through the other one, it's probably an emergence. So you might be able to even shorten the analysis time by using boxes cleverly. I mean, you would know yourself how bats behave and what kind of expectation you're looking from, where it's coming from, and you can maybe eliminate some of those false positives by setting up multiple regions of interest. There's no limit as far as I know. I've set up before to about a dozen for different applications with research. When people looking at circuit boards, they'll have a region of interest on every chip and they'll be comparing the temperatures. So as far as I know, I've never hit a limit. It might just be probably the processing power of your PC. I think it might get a little bit annoyed if you set up 20 or something like that. But yeah, is that answer your question, Sean?
Yeah, that's great. It sounds really useful actually. Like you mentioned, having almost rule-based boxes would be useful for something like a bridge. So
yeah,
one direction and not the other could be really, really useful.
That's it. And I think I'm not an ecologist, so I couldn't say specific scenarios, but I'm sure when you're looking at a building, you can work out based on that. But no, thanks for the question. I'm glad you asked that actually, because it's something I forgot to mention before. Any other questions at all? Just say hit the raise button.
Yeah, Andy, Jake's got a question about the purchase cost of the full equipment setup.
Okay, so the equipment is quite is quite expensive. The A700 kit. So we're using with our high kits the most premium fixed camera that FLIR produced until you get to the actual cooled cameras, which are not really well designed to be used outside and a bit cumbersome. They're huge things. We are working on some purchase packages for Ecologists as well, and we're working with FLIR to have a discount. I would say if you do have an inquiry, I'm just going to pop my email in the chat. Send me an email to here. We can really we when we give prices for FLIR, we have to be careful not to be too public with the way that they publish their prices. So if I put my email there, or you can email Jeffro, and we can put together a quote for you. But you're probably looking, depending on, we have got more entry level models which will do the same job, be just as effective, but you're looking round about the region from about 6,000 up to about 15,000, and then you maybe have the extras, such as if you do want the tripod and all the other extras and extra lenses, but it's round about 6,000 to 15,000 depending on which model you go for. But if you are interested, feel free to email me, and I'll be happy to put together a quote. If you let me know your budget, we can see what we can do. So it's answered. Any other? I'm not really keeping track of the chat, Jeffro.
Kerry's got one just asking about the waterproof. How waterproof is the equipment?
Okay, so the tablets we've got are the IP67 rated. They're kind of designed to be used outside. The cameras are IP65, I believe. So they're kind of a bit of moisture, a little bit of a shower, they're fine, but they're not designed to be left out in the rain. So I think they're almost like, if we're going to actually maybe have a bracket on the tripod as well, where you can have an umbrella, or maybe just have a shielding on top of the camera in case there's any a bit of rain that you might stay out in a survey for, but you're concerned that the camera might get a bit wet. So if you hear some banging, it's typical the day that I'm doing a webinar, I've got workmen fixing paneling on the outside of our building. So if you hear banging, I apologise. Yeah, so we are looking. It's something we're going to add to make them weatherproof. So they're basically, if you can be outside, the cameras can be outside. Any other questions, Jeffrey? Well, if anyone else wants to answer a question, just put your hand up in the.
Yeah, Sarah's just asking about the cost of just the software.
Okay, so there's another question earlier as well about using the software post processing and how long they can use the software for. So I'll try answer both of those in one. So the cost of a software for Ecologists is around about £500 a year. Now, there's if you don't wish to pay for this software, we provide the software with the cameras anyway. So the duration you have the cameras, you have that software. Now, we realize when you send the cameras back, you're not going to have enough time to process that. So FLIR do provide a free version of the software, but there's an extra step you need to do. So when you've filmed your survey and you've got your data files, you can open up in Research Studio, and there's it's 2 clicks. You press export, and you export as a Research Studio player file, and that means it converts it to a read-only file. Now, it's only read-only in the sense that you can't splice it up as the metadata file. But what you can do is you can open that up in the free version of the software, and you have all the same analysis tools that I've showed you. You can also export it as a video file, certain little clips if you want. It's got all the same capability. The only thing it can't do, that software, is record new footage, and can't open up the original recorded files. It's just a step to record them. But what you'll probably be doing anyway when you record the original files, you'll be transferring them over to another SSD from our device. And instead of transferring it over as a direct copy and paste, what you would do is press the export button and export as a read-only file to your own device. So it is an extra step, but I think it's one of those things, once you're shown, it will just become part of your workflow, that you will record them and you'll export them as a read-only file, and you can use the software. And I say it's not limited in any way in the sense of analyzing the data. So you're not restricted at all. All the filters I've shown you, the layout is exactly the same. It won't connect to a camera, which if you don't own the camera and you're hiring, it won't affect you at all. But we will we can certainly instruct you how to do that. I hope that makes sense. It sometimes comes out of my mouth a little bit confusing. So if anyone's got any kind of questions or just a little bit of clarification on that, I'd be happy to answer that.
I did see Oliver. I saw you raised your hand. I don't know if Andy's answered your question
I missed that.
already,
Sorry,
or if you still had a question.
I know that's okay. So, but yeah, if anybody else has a question, either type it into the to the chat, or just raise your hand. And if anything comes up after the call, be happy to answer the question as well. Often you can come off a call and then realise you've thought of something. We do just really encourage people. We have had a lot of ecologists try it already, and the feedback we've got has been amazing. Lauren, who has been actually doing our job for us in the chat, thanks Lauren for answering so many questions. He's been using them and he's given us a great testimonial, and many of us have been using our kits already. So it's been a great opportunity to reach out to a lot of people at once. But we do encourage you just to try our kit and see what you get out of it. We're very confident now that a lot of people have used it that it will improve your surveys, it will shorten your post-processing time, and it will give you the confidence that you will know for sure if something is there. You won't be second guessing or wondering where a particular bat has come from, or if there is an emergence there. We can give you that empirical evidence that there is or isn't a bat. And I say the feedback we've been, I'm probably trying to be a bit more modest about it. In the past, when I've spoken to people, I was very reluctant to say it can do everything, but the feedback we're getting from ecologists is it's exactly what you guys have been looking for, and we'll just give you the confidence that you have when you're doing your surveys. But yeah, if there's no more questions,
yeah, Andy, there's one from Olivia just asking how large in gigabytes is a 1.5 hour thermal video.
Okay, yep. So it uses, if you film at 30 frames a second, it's approximately a gigabyte a minute. So a survey that lasts, like say 1.5 hours, that's going to be would that be 100 and it'd be about 90 gigabytes.
We've been talking about how we can manage that with different storage systems like SD cards and SSD drives.
Yeah, so all our tablets with our kits come with a 1 gigabyte SD card with them.
1 terabyte.
Sorry, yeah, 1 minute of recording. 1 terabyte of storage. So what we would recommend is if you bring along to the survey so if you've got, even if you've got 4 cameras on a survey, that will fit onto a 1 terabyte SSD. And if these cost 20, 30 quid nowadays, it's not a lot of money. This was a big problem in the past, but storage is much cheaper. Once you've analyzed the data, and if you need to store it for long term, you can export it as a video, which is what you would only have if you'd recorded with a scope or an IR anyway. You'd have it in a video format, and if you want to save space, you can delete the what we call the metadata files, which are very large. I did mention earlier, because the videos are only 640 by 480, because thermal imaging cameras are much lower resolution than visual cameras. They're actually very small videos. Small videos, they take up very little data anyway compared to a HD video or a 4K video. Is there any other questions there?
Yeah, I don't think I've missed any in the chat.
If I have missed anyone, just if you don't mind popping it in there again, or just raising your hand.
Yeah, we've mentioned a couple times in the chat, but for anyone who has missed it, we will be uploading the recording to YouTube and LinkedIn. We'll be putting it on our website as well, and adding in a little like Q&A section. So all of the questions that have been asked today, you should have pretty easy access to the answers within the website as well. So that should all be up and running in about a week or so.
Yeah. I would say as well, what we've developed is really been in the last 3 months, and we're always looking to, for example, the last advanced tracking detector I showed, we only developed that 2 or 3 weeks ago. I'd have Ellie, if she's still on the call, to credit for that, for her footage of a meadow. So we are looking always to improve. So if you do have any ideas or things you'd like to see, or maybe things that would improve what we already have, we're very open to suggestions. We can't promise we'll hi Ellie. Yeah, I can't promise that we can implement everything, but it is really good to have that feedback. So not just questions, but if anybody's got any suggestions they want to make, that would be fantastic as well. We're in this for the long haul. We want to kind of keep building on this from this is our first season, and in the coming years to really keep working with you guys to give you what you need to make your jobs and your lives easier. So if So yeah, so if there's no other questions, which I don't think I'm missing, I think we'll probably call it a day for now, and I'll just say thank you everyone for joining. I think we had over like 100 there, which was way beyond what we what we expected. We've been happy with maybe half a dozen of you. So thanks everyone for joining. If you do want to try it, send us an email or go to our website and just send us a message and what dates, what kind of survey you're doing, and we'll quite happily have a call and kind of work with you and sort out a package that works for yourself. But yeah, hopefully we can kind of keep on working you guys for a long time to come. Any final thoughts, Jeffro?
Yeah, I'd just like to reiterate, thank you everyone for showing up. As I mentioned earlier, we know it's right in the middle of the season, so it's great that you could spend this couple of hours with ourselves. And yeah, if you're interested, just get in touch. We're more than happy to jump on a call to just run over anything, any questions that you've got, or if you've got a potentially tricky project coming up which you don't really know how it would work, we're more than happy to kind of lend our expertise on that as well. So yeah, thank you everyone.
Yeah, so thanks everyone. Yeah, we'll end the call now. So yeah, hopefully we'll hear from some of you in the coming weeks. Thank you. Bye.
See ya. Bye bye.